In this lecture we will see what is sampling process and what is sampling theorem. So first of all, what is sampling? Sampling is nothing but the process to convert continuous time signal into integer multiple of sampling interval into discrete time signal, okay, at integer multiples of sampling interval. Actually, the relation between continuous time, this is denoted by t, and discrete time, which is denoted as small n, is this, and t is equal to nts, where ts is sampling rate. Okay, so this is continuous signal and this is discrete signal, which is shown as a train of impulses at integer value of time, ts, 2ts, 3ts, 4ts and 5ts. Okay, and sampling instance means amplitude is xts, x2ts, x3ts, okay, according to the envelope, according to the given input signal. This is the envelope. Okay, and what is sampling theorem? Sampling theorem states that band limited means signal is limited, not avalanche. Band limited signal of finite energy which has no frequency component higher than ohm h. Ohm h means omega h. Okay, this is radian per second. Okay, you can write omega h in terms instead of ohm h. Okay, and it is ohm h and it is minus ohm h. Okay, band limited, and band limited signal is maybe square, maybe triangular, any type. Okay, and how to process? This is sampling theorem. If ohm h is greater than or equal to twice of ohm h, means sampling frequency should be greater than or equal to twice of highest frequency, maximum frequency. Okay, or we can write fs should be greater than or equal to twice of fm. Okay, and what is this criteria? We will see. This is xt and this is st. Okay, we have to convert the signal into discrete signal. So what we do? So we multiply y is the output, we multiply xt signal into impulse train, which is denoted as st. Okay, so this is the Fourier transform of xt, which is shown as a band limited ohm h minus ohm h. Okay, frequency, this is frequency, and this is radian per second, and this is the Fourier transform of this. Okay, and we can see maximum amplitude is ohm s. Okay, this is the Fourier transform of this, and we get after multiplication of these signals we get this, and Fourier transform of this is this. Okay, and maximum frequency is, and maximum amplitude is fs. Okay, and how we get? First of all, this is impulse train is denoted as this summation. What impulse is? Delta d. Impulse train means sequence, delay sequence, okay, and advance sequence. Okay, okay, this is the impulse train, you can see, and we can write it as a this. Okay, and impulse train is multiplied into xt signal, which is uh, this. Okay, and if we multiply, we know this property, and after that we can write this. Okay, and we can see x ohm x delta t after multiplication, and this is this. Okay, and we know you can see xt property. Xt is multiplication st, means two signals are multiplied in time domain, then we have to convolve in frequency domain, and this is the property x ohm or x omega convolution x s omega, yeah, s ohm. Okay, this is a property. If here is convolution, then then simple multiplication in frequency domain. Okay, so we have write. Okay, and this is the Fourier transform of impulse or impulse train. Okay, so we can put s ohm here. Okay, so we get this. After that we get this, and we know the property, s ohm convolution into delta is equal to x delta minus x ohm minus ohm s. Okay, we know x t naught x t. Okay, x t convolution delta t minus t naught is equal to x t minus t naught, we know. So using this either in frequency domain, either in time domain. Okay, this is the property, and we have used this property here. Okay, we get this. Okay, in this is in frequency domain, and this is in ohm. Ohm is frequency omega radian per second. Okay, if we extend this, we get this, and if we draw this, we will draw this. Okay, maximum amplitude is fs, and here we can see maximum amplitude is 1 by ts. 1 by ts means fs, and if we start from minus n equal to minus 2 this, n equal to minus 1 this, n equal to 0 this, n equal to 1 this, n equal to 2 this. Okay, and in this lecture we finish lecture 1. So in next lecture we will see analyzing and proof of fs should be greater than or equal to twice of fm. Okay, thank you.